Hello and welcome to Flotilla update number 35. It's an amazing number of updates.
It is. We keep kicking them out. Yes, we've got 4 new modules to show you today. These are all from our kind of production sample batch from the 150 units we're making of every module so that we can test the production process goes well.
Yeah, so they have the right colours, the right bits on them, everything's as it should be when you get it.
Absolutely. So we start off by looking at the joystick.
Ooh.
Phil? To the
Close
close-up!
Oop, no, wait.
Not
Close up!
Close up!
Yay!
Man, I think people saw me picking my nose there.
Such a pro.
Okay, so this is a joystick, and this is a standard Xbox joystick, like you might get to replace one in your controller if you're kind of that into hacking. It uses 2 little rotary potentiometers, which are basically mounted kind of at 90 degrees to each other, so they'll do both axes. And obviously, by default, Flotilla can't speak analog, so on each joystick module we've got a tiny little PIC 16F1503, which sits right out there on the edge.
So that's about as dumb as a microcontroller gets, isn't it?
Yeah, it is.
Yeah.
They're very, very basic, very, very cheap, and they kind of lend themselves very well to this exact kind of thing, doing a single purpose task. And in this case, we haven't managed to squeeze it under the joystick because there's just no space there.
There's no cavity under these joystick modules,
No,
is
not
there?
at
There
all.
never is. They're
We
all
generally
the
like to
same.
hide them because it makes the devices look really magical. When you get an analog device and it suddenly magically talks through a not USB cable, then it generally looks quite magical. But in the case of the joystick, we just couldn't make it so.
So basically we have the PIC on there. We use the ADC channels on the PIC to sample the X and Y axis on the joystick.
Yeah.
And we also hook up the button because it's got a click button
Oh yeah, clicky button.
in there as well. The PIC scrambles that data, sticks it in some registers, and then basically emulates an I2C device so that the Flotilla dock can talk to it and read off the current
Or
position.
anything that can speak I2C and
Oh,
connect to
that's
those wires.
Yeah, that's true. We'll
Yeah.
definitely do some like Flotilla to breakout cables in the future because
Yeah.
quite nice to be able to integrate with them.
With your Arduinos.
Obviously the joystick, I mean the primary reason we've done a joystick is for controlling things like buggies because it's perfect for that. So, and maybe like an Etch-a-Sketchy style thing or something, that could work quite well. So yeah, it's a useful module. And they're nice. They're technically, kind of mechanically very interesting, aren't they, these little joystick modules? They work really well.
Yeah.
And
They've kind of been through the it's like the USB connectors. They've been through the fire of being used in millions of Xboxes.
so
Yeah.
many things. Yeah.
Yeah.
We're pretty reasonably sure these are good joysticks.
Yeah.
And we've
Yeah.
got shiny green caps on them as well.
Ooh. Next up we're going to look at the slider, which is very similar to the joystick in that it uses the same PIC chip to sample the ADC values, but we
But where
actually
is the
managed to put
PIC?
it underneath the slider, which is rather nice.
Oh my word!
So that kind of hides it out of view.
It's hiding.
And the other thing with the slider, similar to the dial, is we put a row of LEDs up the side, because frankly everything is improved by a row of LEDs. So in default mode, those LEDs mimic the position of the slider, which is quite nice when you're making like interfaces and things. We're using it on the instrument kit as part of the Mega Treasure Chest. But when you get more advanced and start talking to Flotilla through the Python API, you can actually control those LEDs individually. So they don't have to just track the slider. You can use them for user interface statuses and things like that, which is kind of cool.
Yeah.
So yeah, it's a nice module.
Next up, number.
Number.
So this is along the same lines as the Matrix. In fact, uses the same driver chip, which is very carefully hidden right underneath there. Which side is it on?
Yeah, it is there. You can see it.
And we've got the inductor the other side as well, hidden under there.
Yeah,
haven't we?
they're both equally large things that look like each other, but there you go.
Yeah.
So that is driving the 34 elements that make up the display. And you can use this to display things like the time, display temperature, display high scores for games, and all other little things like that. And if you're sufficiently kind of inclined, you could use it to display text. You could stack a couple of these together,
Yeah.
get a Python script up that displays words across here. Obviously W's and M's are a little bit tricky, but
There is like a standard alphabet for those kind of displays, though. Obviously, it's some of it's
you
a
can
little
get an M just by
representative,
turning it that way.
Well, yeah, that's true.
But you have to hold it that way, kind of every word.
Keep flicking it around.
It's also really good for making a bomb. Clock.
Clocks.
Always a clock. Yes.
Definitely clocks.
Definitely a
Yeah.
clock.
And then last up, we got the color sensor, which is probably my favourite.
Last
It's
but
just
definitely
kind of
not least,
awesome. These kind of colour sensor chips, you need to provide a light source, so we've got a couple of LEDs on there. They're just pure white. And it can sense the colour of objects that are held kind of within around a centimetre above the sensor or so. But they're great for lots of uses, for things like identifying objects, like in your classic M&N sorter, or using as the line followers for robots, because when you turn them over and with the light reflecting off the ground or the surface, they're ideal for kind of tracking the line.
Yeah. Can you do extreme close-up on the LEDs and the sensor?
Extreme close-up.
Well, these sensors are really cool. So these sensors are actually like a little grid array, and they have coloured filters. Keep trying. Let's see. You just got to keep your hand steady. Keep your hand steady.
No.
Down a bit. This is beautiful. So right in the centre of that chip, there is, I think with this one, I think it's 60 of them have got a blue filter over, 3 have got a red filter over, and the rest are pure white, because it can actually measure RGB and luminance. Basically.
Yeah.
Can I breathe
but they're really nice little packages.
Not yet, Phil.
Look at that. It's beautiful.
So left and right of the sensor, you can see the LEDs there. And because it shines its own light, it means it gets consistent colour information.
Mm-hmm.
No matter it, instead of relying on whatever light might be in the room, and you might have orange bulbs on, you might have other kind of things on, stuff that really will change what colour value you're getting. So that's why it's got its own LEDs on.
The main problem also, because the sensing distance is quite short, obviously the object would always cast a shadow on the sensor.
It's very hard
So you have to provide a light source, like a bouncing light source that comes up and straight back down off the object to be able to see it, because otherwise it would get rather dark under there. But
yeah.
Having, knowing the temperature of your LEDs obviously helps you calibrate it and make it consistent. But the colour sensor is really cute. And then the last thing we were going to show you today is that this week we received our module envelopes, which go into the box. So we now have a pallet of these in the warehouse ready for the modules to go into. Each module has its own box, which has a label on there. And then, Phil, if you want to go to the close-up. You can see that the box has like a little description of what the module does and what you can use it for. And they're just really cute, really nice.
So we've got things like we've got the icon on there, we've got the name on there, so it makes it very easy to identify the box and then find the module inside it. Great for classrooms, great for kids, and just to get you started with some ideas and things. And there's room in there for if you get more modules in your collection, you can stick them in there as well.
You can't put that one in
put
there,
that
Phil.
module in there.
Yes, I can.
No, you cannot.
Well,
so if you end up getting more colour sensors or whatever, there's plenty of space in the box to store them.
Or if you want to lend out the modules or something, you can just lend them out in a little envelope, and it means they don't get lost. Yeah!
We're super happy with those, they're dead cute. The last 2 things we're waiting for on the packaging are this platform here. We're just waiting for the printed version of that to arrive. And that's it for the packaging, right?
The box inside.
Oh, and there's another box,
Yeah.
There's a larger box that's similar to these, and that's the box that contains the motor, the joystick, basically any module that won't fit inside an envelope of that width.
Yeah.
We have like a catch-all box for everything else because, well, they're awkward. So, yeah.
Cool.
There you go.
That's everything, I think.
I think that's it. That's it for update number 35.
Right.
We are getting closer and closer. Next week it's a text update. We'll probably be talking mostly about production and how the progress is going on that.
Oh, the dock has been approved for production now.
Oh, yeah.
The final dock, we can say Ragworm, start making them. In fact, Connor, start making docks.
Stacey and Connor, if you're watching, that's the order right there.
Yeah. Brilliant.
Yeah. All right. See you later, guys.
see ya.